Hello viewers, welcome back to another section of my tutorial, and in this video I have an IVP here. In my previous video we solved several differential equations problems, so kindly subscribe so that you watch all those videos to help you with your studies. Now it says solve the IVP initial value problem of this separable differential equation I have here. X divided over dx is equal to the square root of y squared plus 1 where x is greater than 0, y equals 0 at s equals 2. Now if you have idea about this, you can pause the video and solve to see your answer at last, or you can solve it together. So let's see, we have our solution. So to start with, this differential equation is a separable differential equation. So we are going to have x dy to be equal to dx multiplying the square root of y squared plus 1. So once you have this, we have separated the x and we separated the y. But the next thing to take note of is, in separation, we always integrate the separated functions with respect to the various components. So we integrate x with respect to x, we integrate y with respect to y. Hence, I'm going to bring this one down here, then simultaneously I'll bring s also down here. That is going to give me the y out of square root of y squared plus 1 is equal to the x on x. So at this point, this will be equal to 1 out of square root of y squared plus 1 dx to be equal to 1 out of x dx. So I'm just going to take integral of 1 over square root of y squared plus 1 dx to be equal to integral of 1 over x dx. Now how do we go about this? You can refer from your calculus, that is calculus 1, to see how we go through this integration. But for this tutorial, I'm going to jump to write all the answers. So now let's see. We know that if you have this becomes the inverse trig differential. So you have to go and refer. And this is the same as sine h inverse of y should be equal to integral of 1 over s is ln of x then plus c. This is the same as arc sine h of y, and this is equal to ln of x plus c. So at this point, I'm going to make some substitution here so that it will make our differential equation become simpler. So what I'm going to do is, whenever you have arc sine h of y, is the same as in logarithm ln of y plus the square root of y squared plus 1. If this is your first time of noticing this, write it down so that you apply it whenever you are solving your differential equation. So ln of s plus c. To make y the subject, this log to the base e, so e to the power this will give me this. So I'm going to have y plus the square root of y squared plus 1 to be equal to e to the power ln of x plus c, and this should give me y plus square root of y squared plus 1 to be equal to e to the power ln of x multiplied by e to the power c, and e to the power c is the same as c, so I'm going to have my y to the plus y squared plus 1 to be equal to, if I have e to the power ln x, the same as x, e to the power ln function becomes the number, so x multiplied by c, e to the power c will become c because it will be a constant at last. So at this point, I'll move y here so that I'll get square root of y squared plus 1 to be equal to xc minus y. But first, let me apply the initial condition so that I find the value of c. This is a general solution for our equation, but let's find a particular solution since it's an initial value problem. So they said that wherever x is equal to 2, y is 0. So I'm going to put s2 and y 0. So square root of 0 squared plus 1 to be equal to 2c minus 0. And this will give me 1 is equal to 2c. Therefore, c is equal to 1 out of 2. At this point, I'm going to put it in this back again to get my particular solution. So square root of y squared plus 1 is equal to 1 out of 2x then minus y. So at this point, I can make y the subject by taking the square on both sides here. Simple algebra. So I'm going to get y squared plus 1 to be equal to, the square of this, I get 1 out of 4x squared minus 2 open bracket 1 out of 2x y, then finally plus y squared. So I'm going to get y squared plus 1 is equal to 1 out of 4x squared. These two cancel this, minus xy plus y squared. Then the y squared will cancel this y squared, giving you 1 is equal to 1 out of 4x squared minus xy. So at this point, what do I get? I'll bring my yx here or xy here, and I'll get 1 out of 4x squared minus 1. To find y is equal to dividing through by x, and that's going to give me 1 over 4x minus 1 over x. This is your particular solution and the explicit solution for this equation. Thanks for watching and kindly subscribe.